or the state diagram. Now, how do you know what it does? In other words, what's the language of this automaton? Or another way, like, what properties the input signals, the strings, what properties in common do those accepted strings in the language have? Right? In other words, what's the function of the automaton? That's not so obvious here. So you have to think about it now. And how to do that? Well, you input various sample strings and see what happens. And then you notice, hopefully after a while, you'll notice patterns, things in common amongst the accepted strings, and those properties do not exist amongst the strings that are rejected. Right? So, doing that kind of thing is called experimenting. You try different input strings and see what happens. So they're called experiments. So you just input various different strings and see what the result is, and see if you can find a common pattern that the accepted strings have that the rejected strings don't have. Right? You're trying a kind of classification rule. If you've ever done any machine learning and artificial intelligence, that's what you're doing. Right? Okay, let's do that for M2. This automaton here. Well, so let's do an experiment. So we'll input the same string that we're used to, 1101. Remember, you start from the left and input one symbol at a time, sequentially, a sequence. So you'll input 1, 1, 0, 1 in 4 steps. Okay. So what does M2 do? What's its function? What's its job? Alright, so I'll use my finger again. Now the start state is Q1, we know that from this arrow. So we start in Q1 and we read 1. Okay, so now we're in Q2. Okay, and then we read 1 again, back to Q2. And then we read a 0, takes us to Q1. And then we read the final 1, takes us to Q2. And that's it. We've finished reading the input string. So the final state is Q2. But the final state is an accept state, because Q2 has 2 rings, right? Two circles. It's an accept state. And that means when your final state is an accept state, then that string is accepted by the automaton. So this particular string is accepted by M2, by this second automaton. Alright, so you do other experiments, you plug in a whole bunch of different input strings, and you come to the conclusion, after all these experiments, that, like, for example, say you input this one. Let's do it fairly quickly. So the input string is 110, okay? So the first one takes you to here. The second one takes you back to here again. And then a 0 takes you to here. And then you stop, because you finished reading your input string. But your final state is not an accept state. Right? You don't have two circles here. So your automaton M2 rejects this string. Okay. Now you do a whole bunch, and eventually you'll come to the conclusion that if you have a final one, it accepts. M2 accepts that string. But if your final symbol is a 0, it rejects it. Okay, so there's your rule. There's your classification rule, if you like. That's a description of the function, the job of your automaton. Right? So So in terms of what's the language? So the language of machine M2 is the set of strings W, where W ends in 1. Right? So that's your sort of classification rule for the input strings that are accepted by M2. Right? So the language of M2 are those input strings whose last symbol is 1. Okay? Alright, now here's another example. Alright, just start on it. Oh no, I think we finished. Okay. Well, here's another example, example 1.9 in the text. Again, it's just a fairly simple automaton, just 2 states. Okay, so you could have this could be a computer with just 1 bit of memory to memorize which state it's in. Okay, so this is now M3, our third example. So here's the state diagram of M3. In this case, you've got something. This is new. What we've got that's new here is that the start state is also an accept state. We notice the start state, here's your disconnected arrow, the indicator of the start state, but and it's Q1, but Q1 is also an accept state. Now that means, if you think about it, that you could have a input string that's the empty string, like eta. Remember that was the symbol for the empty string, the string with no symbols in it. Okay, so if your input string is eta, nothing, no input string, then there's no transition gets made, right? So it just stays here. So the final state is Q1, but Q1 is an accept state. So this automaton accepts the null string, the empty string. Okay. That's just sort of a remark. Now, okay, what's this language? This automaton's language. What property, what's the classification rule, if you like, of the input strings in this automaton's language? What do they all have in common? Well, you need to do some experiments, and eventually you'll find that the language that it accepts, recognizes, is either the input string is empty, so eta, or the string ends in 0. Ends in 0. Well, let's try something. So let's say we input 0. Input 0, so you're back to here. And that's it. So that's accepted. Let's try 1, 0. 1. So start here. 1, 0. So that's okay. So how about 1, 0, 1? Start here. 1, 0, 1. Reject. Okay. How about 1, 1? Start here. 1, 1. Reject. Okay. So you could try, do lots of experiments, and you come to the conclusion that if your input string ends in 0, this automaton will accept it. Okay. Now you're probably feeling, well, what if your classification rule, your description of your language, what if it's wrong? What if you think it's right, but later you keep doing more experiments and you find that it's actually wrong? It's, you find exceptions. Good question. Maybe I'll come back to that later.